A very good afternoon to all of you. Welcome back to my channel. This is Shivam Shukla. Here I am to solve a problem on engineering mechanics. It's a problem on dynamics. It's a problem on work energy principle. Type 2. Problem on combination of work done by applied force, spring force, that is there are two springs, and a weight force. Let us see how the question statement goes. What are the given data and to find. Let's go ahead with one by one. Figure shows a collar of mass 20 kg which is supported on the smooth rod. Smooth, that means friction is not there. The attached springs are both compressed. 0.4 meter. Let us take it very seriously. Initial compression of the springs are given to us. That is 0.4 meter. That is x1 is 0.4 when distance d is equal to 0.5 meter. Determine the speed of the collar after the applied force F is equal to 100 Newton causes it to be displaced so that D is equal to 0.3 meter. Friends, D is equal to 0.5 meter was the position number 1. D is equal to 0.3 meter is position number 2. Knowing that the collar is at rest when D is equal to 0.5 means at initial position velocity of the collar is 0. We are supposed to find the velocity of the collar at position 2. Let us write down what is given to us and what are we supposed to find. So I'll be writing it down over here, my dear friends. Okay. So over here, given data is collar's mass is equal to 20 kg. Again, it's supported on the smooth rod, that is no friction. Springs are compressed in the initial position, both the springs. So x1 is equal to 0.4 for both the springs. X1 is equal to 0.4 meter for both the springs. I can write it like this. Okay. Now what about the further part? D is given. Determine the speed of the collar. This will be to find force F is equal to 100 Newton and displaced second position is given. Initially we are given velocity at position number 1 is equal to 0. Okay. Now what are we supposed to find? I'll be writing to find it will be velocity at position 2, that is V2. One more thing, I can write S is equal to H, that is displacement is nothing but from position 1 to position 2 it will be only 0.2 meters. I just need to draw this diagram again, my dear friends, showing the position number 1 and position number 2. So I can draw it very clearly over here. Now I can just complete this diagram. Now if I set the position number 1 and position number 2 to be very specific, this will be position 1. This is 1. This is number 2. Over here, position number 2. I can write it very specifically, my dear friends. So position 1 is this, position 2 is this. For position 1, this is the distance. That is 0.3 meter. Position 2, it is 0.5 meters. 0.3 and 0.5 meters. So this is 0.3 meters and this is 0.5 meters. Now friends, let us go for writing down the solution. This was the step number 1 to draw the FBD. I can write it over here. Step 1 is to draw FBD. Step 1 to draw the FBD. Now step 2, let's go ahead, is to start with the solution. Step 2. solution. Now I'll be writing it over here. First, kinetic energy, that is Ke at position 1. Position 1 is equal to 0. Why? Since it starts from rest. Since it starts from rest given to us. If I ask about kinetic energy at position 2, if I say about kinetic energy, Ke at position 2, it will be equal to half into m into v square, sorry, v2 square, and that will be equal to 0.5 into, what is the mass given to us? 20 into v2 square. No need for the calculation. 0.5 half of 20 is 10. So 10 into v2 square in terms of joule. So it will be, this was T1. T1 is equal to 0. And this is nothing but T2, kinetic energy at position number 2. Now we will be going ahead with work done by different forces. Friends, it is very important by reading the problem, you'll read it again. There are total, by and looking at the diagram, there are work done by total how many forces in the problem. So now first is, since the initial position is up, the final position is 2. First and foremost, there is going to be a weight force because it's in a vertical plane. So m into g into h. Second will be, since there are springs, there will be work done by spring force. And third will be, since there is an applied force F, there has to be a vertical component of force because the displacement of the collar is in the vertical direction. So let us write, show that as well. So let's go ahead with that. Okay. Now, step number 2, it was the part that we went ahead. Now step 3 is of course of the solution. But now we'll be writing down work done by different forces. So it is step 3. Step 3, work done. First is work done by weight force. Work done by weight force is equal to m into g into h. M into g into h. Of course, friends, it's gonna be plus. Why? Because the initial position is up, the final position is 2. Down. That is why. 20 into 9.81 into 0.2. Why h is 0.2? Because it is clear cut given that the displacement is by 0.2. Now, the equation, the value is gonna be u1. It will be 20 into 9.81 into 2. So it is nothing but 392.4 joule. 392.4 joule. 392.4 joule. Second, work done by applied force. Work done by applied force. Force is equal to F into sine theta. It will be the vertical component of the force. My dear friends, if I show F over here, very specifically I am going to show F. This will be the force. If you can see F over here, F is equal to 100 Newton. And if I just resolve it, it will be easier for me to resolve the force F. So it will be, this is F cos theta, this is F sin theta. So amongst the two, I am going to consider only the sine component. 100 cos 60, 100 sin 60. Why, friends? I am going to consider 100 sin 60 only because it is this component of force which is causing the displacement of the body in vertical direction only. That is why the formula is gonna be F sin 60 into S. So it will be F, I'll be writing it F sin 60 into S. So it is gonna be Since both are in downward direction, that is why the value came out to be positive over here, because we will be considering in downward sense as positive or upward sense as positive. The value is supposed to come as positive. I will be writing just for your convenience. Work done in downward sense as positive you have taken. Work done by weight force, even this in downward sense as positive. So things will be clear and easier on our part. So it will be 100 sine of 60 into 2. So now if I do the calculation, it will be 100 sine of 60 into 2. Sorry, 100 sine of 60 into 2 is equal to like this, 173.205 joule. 173.205 joule. Now friends, very important one, last but not the least, is work done by spring force. Third, it will be U2. This is U, not V. Work done by spring force. For lower spring and for upper spring, there are two springs with different values of K. For lower spring, I will be writing U31 is equal to half into K into x1 square minus x2 square. Friends, let me be very specific. If I look at the diagram, go to the diagram, it is very clear cut mentioned to us in the question that the attached springs are both compressed by 0.4 meter when D is equal to 0.5 meter. That means at the initial position, already the value of x1 was nothing but 0.5. We don't have the undeformed length. That is why they have already given to us, that is whatever the length of the spring was there, from there it is directly compressed to 0.4. That is why x1 for upper spring or lower spring is 0.4 meter itself. So that is how I can write it now for this particular part. X1 is equal to 0.0.2. Now already we have given it as mentioned. Now x1 is equal to x1 is equal to, yes, x1 is nothing but already there with us, and the value is x1 is 0.4 meters. Value of x1 is 0.4 meters. Sorry, I mistook it as 0.2. x1 I have already mentioned it over here. x1 is 0.4 meter for both the springs. Already we have written it down in the question. So x1 is 0.4 meter. Now for x2, friends, now you need to think over this. Very specific it is. I'm just talking about the lower spring. Let us just concentrate only in the questions diagram and on the lower spring itself. If the initial position was like this and both the springs are compressed, now in position number 2, the lower spring is further compressed by 0.2 meter. So friends, since it is a further compression, means the initial position of the lower spring was somewhat up, and then it was compressed by 0.4. Now it is further compressed by 0.2. Then what is going to be the actual compression? So it will be, I hope you would have understood how I will be writing x2. So x2 will be nothing but over here 0.4 plus 0.2 is equal to 0.6 meters. So now we got the clear cut value of half k x1 square minus x2 square. So x2 is there with us. So I can write it u31 is equal to half into k. For lower spring, what is the value of k? It is nothing but 25 Newton per meter. So I'll write it 25 into 0.4 square minus 0.6 square. Therefore u31 is equal to, I'll be doing the calculation, 0.5 into 25 into bracket of 0.4 square minus 0.6 square. Sorry, 0.6 square. I can complete the bracket like this. So the value is minus 2.5 joule. I'll be writing it over here, minus 2.5 joule. Now for upper spring, I'll be going ahead. For upper spring, friends, let's be very clear. X1 is going to be the same because it was written initially that both the springs are compressed, initially compressed, that is X1 is equal to 0.4 meter. But now you are expected to predict this, my dear friends, X2. What about X2? If I see the diagram again, if I see the questions diagram again, now it was in an initial compression, my dear friends. The spring was in an initial compression from its normal position by 0.4 meter. So X1 was 0.4. But now if I see in position number 2, this upper spring is stretched. That means it is moving towards its neutral position now. So by how much it went? By 0.2 it went. That means whatever the value is there for the extension, it will be now X2 is equal to what it will be. It has extended. That means the value of X2 is going to reduce now because it is coming towards the neutral position, my dear friends. So 0.4 minus 0.2 is equal to 0. By how much? 0.2. So 0.2 meters. So now U32 I'll be writing. Therefore U32 is equal to half into K is 15 into X1 square minus X2 square. Okay, therefore U32 is equal to, let us do the calculation. It will be 0.5 into 15 into in bracket 0.4 square minus 0.2 square. So it will be 0.9 joule. So friends, it is 0.9 joule. 0.9 joule. Now let us go for the last part. By work energy principle, we are supposed to find the value of V2. Therefore, by WEP, that is work energy principle, summation of work done by all the forces between positions 1 and 2 is equal to T2 minus T1. Okay. So it will be T2 minus of T1. Therefore, let's take it one by one. Let's take the value of the forces. 392.4, 173.205, 392.4 plus 173.205 plus in bracket minus 2.5 plus 0.9. Minus 2.5 plus 0.9 is equal to T2 minus T1. T2 is 10 V2 square. T2 is equal to 10 into V2 square. Therefore, only V2 is unknown for us, my dear friends. So I will be writing and doing the calculation. Let's do it one by one. I'll be just taking it to the extreme left over here. So it will be 392.4 plus 173.205 plus 0.9 minus 2.5. Whatever the value is there, divided by 10 is equal to, taking the square root of it, square root of answer, 7.51. So the value is coming out to okay, just let us do the calculation one by one again. Let's go ahead with the calculation, friends. There is some mistake in the calculation. Okay, yes, friends, it is just a problem that we have taken the value as 0. The values are 0.2 only. The calculations are missing. Let us just rectify it one by one. So here it is 20 into 9.81 into 0.2, it will be 39.24. It will be nothing but 39.24. I'll be just writing it now. So 39.24 joule. 39.24 joule. Same way, it is 17.32 joule over here. It is not into 2, it is 0.2 into 0.2. 0.2. So 17.32 it is. To be specific, I'll erase it. I'll just show the value of decimal over here, 17.32. Same way, these are correct. Let us just do the calculations one by one again. Okay, so over here 17.32 plus 39.24, I'll be writing 39.24 plus 17.32 plus 0.9 plus 0.9 minus 2.5, whatever the value is there, divided by 10 and taking the square root of the answer, 2.344. So 2.344 is the final answer, my dear friends. Sorry for the calculation mistake on my part. So this is the way how it will be getting solved. So I'll be writing it over here. I'll be just rectifying. It was 39.24, 17.3205. Rest of the things are perfect. So V2 is equal to 2.344 meter per second. Friends, this question is asked in the university for 6 marks. Let us see how the marks are going to get distributed one by one. If I say for kinetic energy, entire kinetic energy will be giving you 1 mark. Work done by different forces, work done by weight force 1 mark. Formula correct value, work done by applied force 1 mark. Since work done by spring force is quite big, it will be giving you 2 marks. 2 plus 2, 4, 1 for that, and final answer along with the calculation, that is V2, which is the final answer, will be giving you 1 mark. This is the way how the problem gets completed, my dear friends. Please do like, subscribe and share this video. Thank you for watching this video.